So we'll take, select a circular edge. We'll select that. Why is it not happy? Oh, I know what it is. It's in the assembly. It's not happy in the assembly. So I'm going to go to this part and open the part. Really? That crashes SolidWorks? That is lame. Okay, so we'll go to Insert, Annotations, Cosmetic Thread, and we'll select this circular edge, and there's your cosmetic thread. Okay, so it puts a thread on there, but this is just a fantasy. It's just a picture. So it's like a color. It's like red. It's like making that red. Yeah.
How do you make it so that it doesn't go through the whole length?
Oh, that's a good question. I don't know. Let's take a look. So under base body, here's this cosmetic thread. Blind, and then select a distance. So 1. Okay, so, but again, this is a fantasy, and that's fine. I mean, it shows a thread for people that want to see a thread, but it's not real geometry. It's not really there. It's just like a painting, a color. Okay? Alex tried to figure out, hey, I want a real thread. So he went and figured out how to do a real thread. And to do that, you need to do a swept cut. Okay? So let's go ahead and do a real thread on this with a swept cut. Now, to sweep that cut, what you're going to do is just what you saw on your single point. You need to make a tool, orient the tool on that point. Oh, you know what? Before we go into that, if you just open SolidWorks cold, you won't be able to see that cosmetic thread. In order to see that cosmetic thread, you have to go to Options, Document Properties, Detailing, and you have to click this Shaded Cosmetic Threads button. If you don't do that, your cosmetic thread won't show up. And so if you were to open SolidWorks and do that now, I don't think that's checked. So if you, let's put that, I'm going to put that cosmetic thread back in there. We'll do it blind by an inch. You see it's there, but it's not showing. So you have to go to this Options, Document Properties, Detailing, Shaded Cosmetic Threads. That drove me nuts for an hour one day, so I wanted to show you that so you don't get driven nuts. Okay, I'll go ahead and suppress that feature. It looks like they had a cosmetic thread also for their bolt inherent in the bolt from the toolbox. It was suppressed. Alright, so to cut the threads, you need a tool that basically looks like the single pointing tool that Professor Hodgkinson was using. And then you've got to revolve that around in a helical pattern down the screw and cut as you go. So first we need the tool, and it's got to be normal to this surface because it's going to cut around this way. And in order to do that, I need a sketch that kind of runs down the center of this bolt. And so I'm going to need a plane that runs down the center of this bolt. And in order to make a plane, I need 3 points. So I need to start inserting some reference geometry points. And I'm going to do the arc center of that. So that's cool. And I'm going to do the arc center of this guy. So there's 2 points on my plane. And then I think I'll just use that vertex as the third point of my plane. So now I can go to insert reference geometry plane, and my first reference here can be this point, and my second reference can be this point, and my third reference could be this little vertex there. See that plane there? Kind of bisecting this bolt. Alright, now we can make a sketch on that plane. Sketch. And we need to make this tool. Now that tool needs to be in the shape of a thread profile. So I didn't look this up for the other. Let's look up ANSI inch thread profile. And the thread profile on ANSI inch is going to be the exact same as metric threads. They're 60-degree threads. So here's your thread profile. So if you wanted to get a really good perfect thread, you would put this exact profile in. So you've got 60 degrees here. You've got this. There's this theoretical height here. Okay, and then there's a root radius. So you would copy this as your cutting tool, and then you'd get a perfect theoretical thread, ANSI inch thread profile. We're not going to do that exactly. We're just going to go ahead and draw in the 60-degree triangle. So you want to draw in this triangle, and you want to do it on your part here. Also, you need to, in order to do a swept cut, you have to have a closed boundary. So we've got to close in this tool. So I'm going to close it in kind of like the threading tool that you saw, like that. Okay. Now I just drew that in. It's not correct. So we have to dimension this and make it correct. In order to do that, I'm going to draw some lines in here. And I'm going to draw a line across here so I can get an intersection point. So the first thing we know we want is we want 60 degrees here, right? Because that's the most important part of that thread profile for both standard and metric. It needs to be an isosceles triangle, so we need to make sure that both of these angles are 30. So I'll just code that one to 30. Okay, that looks right. And then the next most important thing is this height. That height's got to be right. All right. So we're doing a half 13 bolt here. If you look at this is where the thread classes come in. I don't know if you remember thread classes from the fastening lecture, but there's A, B, and C. This is an class A thread chart. Your major diameter, if you look at a half-inch bolt, half 13, is a ½ inch, which makes sense. That's the outer diameter of that bolt. Your minor diameter is 0.404. That minor diameter is describing, so if you had this thread on this side and this thread on this side, that's the diameter from this point to that point there. That's your minor diameter inside there. And so we want that to be 0.404. All right, so if this is ½ inch, and we subtract the 0.404, we've got 96 thousandths to distribute on this triangle and this triangle. So we divide it by 2, we get 48. So we want to dimension that height to 48 thousandths. Looks like I'm going to have to put a point there. So that I can dimension between them. 48 thousandths. And there's my triangle on my tool. Alright, so you see my tool? And now I need to tell it, hey, I need to revolve this on a helical pattern down that screw. So we need to insert curve helix spiral. We're going to do it on this circular edge. Actually, I had to put a sketch in here. There's probably another way to do it, but I'm going to put a sketch in order to put a circle, and I'm going to snap it to the diameter of that, and then I can go to insert curve helix on that sketch, on that circular sketch. And then you get some options here. You can do pitch and revolution, you can do height and revolution, you can do height and pitch. So let's do let's do height and pitch. So your pitch, you wanted 13 threads per inch because it was a half 13 bolt. So your pitch has to be 1 inch divided by those 13 threads. It's going the wrong direction, so we're going to hit reverse direction. It's going this way. And then height is where we can decide how far it goes, I believe. So this is a 2-inch bolt. We could go 2 inches. Now, if we go the exact 2 inches, that tool's not going to be able to get all the way down there. But let's just do it for fun and see what happens. Alright, so now we have to we've got our tool and we've got our helix that's in the right pitch. Now we've got to perform the cut. So we go to Features, Swept Cut, and the first thing you have to select is the profile. That's the tool that you're going to use. So you have to select this little profile down here. I need to zoom in. I tried to get it to select the whole sketch and it wouldn't do it. I don't know why. So, and then remember, it has to be a closed profile. So it says closed group 1. And then this selection is the path. So the path we want to sweep that along is this helix spiral. And I have a terrible time selecting it. There. Okay, and you get a preview here. It looks kind of crazy, but if you select it, there's your threads. And they're real. So this is actual geometry, unlike the cosmetic. See how we went the 2 inches and the tool kind of dug into the head? So you can't physically do that. So we should have backed that off by at least the width of the tool from there, from the face. But there's a real thread, if you ever needed to make one. Now, another use for that, so in another context, just to show you another use, the altimeter mounts that you're going to make with complex surfacing, I had to make that part off of, I used the mold feature and made it off of a actual bottle. So I had to model the bottom of the bottle first, and I did that with that same swept cut feature. So if you look here, I did a swept cut. I used this trapezoidal type tool and I swept it across this spline curve that I put in on this sketch. You see that? And it kind of cut this trapezoidal path through here. So you can use this cut sweep feature for more than just threads, but I thought I'd do it in the context of single pointing threads. While we're on the topic of threads, just for fun, I wanted to show you a mate that you can do with threads. Alex, you will have already seen this also. But, so this is back to our little blocks. It's our little 1 by 1 by 1 aluminum blocks. Only this time I put a 1/4 inch hole in there. 1/4 and I actually made it real geometry. Didn't have to, but I did. I made it a real cut. And then I put a 1/4 20 bolt in from the toolbox. And then I did this cool mate. And I'll show you the mates. So you can go to mates, and instead of doing your regular mates, you can do what's called a mechanical mate. And you see you have these different kind of mates. You've got a cam, a hinge, a gear, rack and pinion, screw, and U-joint. They're kind of cool. So I did a screw mate, and you can tell it revolutions per inch. So that would be your pitch. So 13 revolutions per inch. So you can tell it that. I'll show you my mate here. So I made this screw mate here. In this case, I did 1/4 20, so I did 20 revolutions per inch. And then I selected this face and this face, which are the cylinders. So I mated cylinder to cylinder and make it a screw mate, so as you move, it turns. The mate alignment tells me which way I'm going, and then you can select, I believe you can select clockwise or counterclockwise. I can't make this guy smaller for some reason. So what that'll do for you is when you try and drag one of these pieces, it screws in. See that? Now the one thing we tried to do is, watch this, it'll keep going. So that's not real, but this would be a cool thing to try and figure out. I don't think you can stop it. So Alex, we decided, or we were going to try and say, hey, stop from that face to that face. Just stop when you hit it. I don't think you can stop it with a mate, because you're moving in 2 degrees of freedom. You're turning and moving axially at the same time. If you try and put any kind of mate in there, it's going to conflict with one of those degrees of freedom. But then I started thinking about it, and what is the purpose of this mate anyway? You would only use this mate if you were trying to show someone that screw screws in, right? So you would only use this mate in the context of an animation. So I think this is just for visualization, for people's sake. So what you can do is you could go to your motion study and do your animation, and you should be able to drag this and then stop when you get up to that point, and then call that the end, right? And then drag it back if you wanted to. So you can basically force it to stop where you want it to in the context of this animation. And now that I think about it, that's really the only reason I could see to have that kind of mate there anyway. It's a movement mate, you know. It's a motion mate. So one thing I don't know if it works is if the exploded view collapse or expand and collapse animation, I wonder if that would make the screw mate work, or if it would show the screw screwing out with that mate. I don't know. That'd be an interesting thing to try. So, any questions about this stuff? Cosmetic threads, real threads, swept cuts, mechanical mates. It's just some cool stuff. All right. That'll be